All right, picture this. You build a standard ChatGPT prompt. It works great. But then you ask it to do something genuinely complex. Say, fetch data from 3 different APIs, dynamically decide which one to actually use, and then loop back if the first one fails. Well, what happens? ChatGPT just breaks. It doesn't loop, it doesn't make dynamic decisions, it just spits out one single text response. And honestly, this is exactly where agents come in. An agent isn't just a prompt, it is an autonomous system, a loop that thinks, acts, observes, and then thinks again. So in today's explainer, we're going to figure out exactly how you can build these powerful production-ready systems right in JavaScript.
Here's our roadmap for this explainer. First, the AI agent loop. Second, chains versus graphs. Third, Langgraph architecture. Fourth, building a research agent. And fifth, debugging with Langsmith.
Section 1. The AI agent loop, moving beyond one-shot prompts.
Okay, so there is a massive paradigm shift happening here. Fundamentally, your standard ChatGPT setup operates on a one-step process, right? You ask a question, you get an answer. Boom, done. But an AI agent, that is a multi-step loop. A question triggers the agent to actually think, to act, to observe the outcome of that action, think about it again, and iterate until it finally reaches a complete solid answer. It's literally evaluating its own progress as it goes.
And that loop basically boils down to 4 precise steps. Step 1 is think. The agent receives a request and asks itself, okay, what do I actually need to do here and what tools do I have access to? Step 2 is act. It decides to fire off a tool, like say, searching the web. Step 3 is observe. It looks at the result and goes, did that tool work? Did I get the right data? And finally, step 4 is decide. Based on that observation, does it have the final answer ready for the user, or does it need to loop right back to step 1 and try a totally different action?
Moving to Section 2. Chains versus graphs. Why Langchain isn't enough for agents.
Now look, Langchain is fantastic, but it was built for exactly that. Chains. Fixed sequential sequences that happen in the exact same order every single time. Give a topic, generate an outline, write the content, summarize it. It's incredibly linear. But agents? Agents require something vastly different. They need a looping, highly dynamic flow. They absolutely require conditional branching, meaning the agent can decide whether to loop or stop based entirely on what it just observed in real time. And critically, they need state management. They need to accumulate memory across these iterations so they don't just forget what they tried 5 seconds ago.
Section 3. Langgraph architecture, modeling agents as graphs. To actually build this out in Langgraph, you really just need to wrap your head around 3 core concepts. First up, we've got nodes. Think of these as the specific, actionable steps your agent can take. You can basically conceptualize your code as having a dedicated think node, a search node, or a decide node. Next, we have edges. If nodes are the steps, edges are the connections that dictate the flow between them. So from a think node, you move along an edge over to a search node. But the absolute secret sauce of Langgraph? Conditional edges. This is what gives the agent its dynamic decision-making superpower. A conditional edge lets the agent literally check its current progress and dynamically route itself. It can choose to loop back and try another tool, or just stop and deliver the final answer.
And the third concept tying the whole shebang together is state. As your agent travels through these nodes and edges, its state is constantly getting updated. This is basically the accumulated short-term memory of every single observation, every tool call, and all the data it's gathered so far. It ensures that when an agent loops back around, it completely remembers what it already tried. No wasted API calls.
Section 4. Building a research agent from concept to architecture.
Let's outline the exact sequential journey of a real, functional JavaScript research agent. Step 1, a user asks a highly complex question, something like, what are the latest developments in AI safety? Step 2, the agent takes that prompt and actually searches the web. Step 3, it reads through the top articles it just found. Step 4, it synthesizes all that raw data. Now here is where the magic really happens. Step 5, the agent checks its own work. It asks itself, do I have enough information here, or do I need to loop back to step 2 and run another search? It just continues this loop until it is fully satisfied and finally hits step 6, returning a beautifully comprehensive answer to the user.
So the big takeaway here, a true agent maintains its state across every single iteration. It calls tools conditionally based on what it actually finds in the wild, and it loops dynamically until its exact stop condition is met. I mean, this looping capability is just infinitely more powerful than throwing a simple sequential chain at a problem. Section 5.
Debugging with Langsmith, monitoring the loop in production.
Now, if you can probably guess, when you have an agent looping autonomously, things can and will go wrong. Infinite loops? Yeah, they are a very real developer headache. And that is exactly where Langsmith comes in. It traces your agent's execution in real time. Just look at the visibility you get here. The execution trace gives you a visual tree of every single step and tool call. The latency breakdown lets you spot your slowest bottlenecks instantly. Token usage tracks exactly how much the specific execution cost, which is a lifesaver for trimming down verbose prompts. Tool details shows you the exact arguments passed to a tool and what it spat back out. And error tracking, if your agent crashes because, say, an LLM flat out refused to call a tool, Langsmith shows you exactly where and why it happened.
So, if you're a JavaScript developer sitting there deciding what tool to reach for, here is the breakdown. Use Langchain if you have fixed sequences, like basic text summarization. Keep it simple. But reach for Langgraph when you need agents that actually think, require those conditional loops, and need to execute complex tool calling. And of course, plug in Langsmith anytime you need to monitor those executions, debug your failures, or optimize your token costs in production.
That right there is the ultimate architectural mental model. Langchain for your simple chains, Langgraph for your autonomous, heavy-lifting agents, and Langsmith to monitor the whole thing in production. This stack literally takes you from basic prompt engineering all the way up to complex autonomous AI systems.
Which leaves us with just one final question for this explainer. Now that you know exactly how the loop works, what AI agent are you going to build first? Are you going to build a code fixer that reads errors and tests its own solutions? Maybe a smart customer service bot? Or a relentless researcher like the one we just explored? The tools are out there, they're ready to use, and honestly, the possibilities are just endless.